So in this video, we're going to talk about concavity. So concave up is if the curve is curved upwards. And how we can kind of tell this is if you draw the tangent line will be below the curve. So if I draw the tangent line, like on all of these spots, the tangent line would fall below the curve. And sometimes they explain it as if I look at it, this would hold a cup of water, it wouldn't dump out. And so that's concave up. And so here it's like this is concave up in a decreasing function, and this is concave up in an increasing function. Now, for concavity, when it's concave up, the slope of the graph is increasing. And this is sometimes hard to wrap your mind around. But what it means is if I looked at the slope here, this would be like a steep negative. So I could say the slope was like -5. And then here it's a little less steep. So this would be like -3, but it's still decreasing. So the slope is negative. Here it's 0. Here the slope is increasing. So this would be like 2 or 3. And then here it would be about the same here, but positive. So it'd be 5. And so I can see as I go along here, the slope is increasing. And so anytime my function is concave up, the slope is increasing. So the second derivative of a function tells us concavity. And if the second derivative is greater than 0 or positive, my function is concave up. And the derivative is increasing because again, the slope is the derivative. So the slope would be increasing. And because the slope is increasing, when I take the derivative again, that derivative is positive. So the main thing we'll talk about is if my graph is concave up, the derivative is positive. That's the key thing. Now, the other one is concave down. So concave down is the curve is curved downwards. So it looks like this. And again, they talk about it as if you try to put water in it, it would fall right out. This is concave down decreasing. This is concave down. Sorry, this is concave down increasing. This is concave down decreasing. If you draw the tangent lines for concave down, the tangent line is going to be above the curve anywhere you draw it. Now, the slope of the graph is decreasing if my function is concave down. So here, this slope would be like a +5, and this one would be a +3. This slope would be 0. This slope would be -3. This slope would be like a -5 because it's a steeper negative slope. So here we can see my slope goes from 5 to 3 to 0 to -3 to -5. And so my slope is decreasing. So the key thing is that because the slope is decreasing and the derivative would then be decreasing, the second derivative is less than 0. And so f of x is concave down anytime the second derivative is less than 0, and we say the derivative, the slope, is decreasing. So a kind of a trick to remember concavity is you can make these smiley faces, and you have Mr. Smiley and Mr. Frownly. If you're concave up, it's like a smiley face, and so the second derivative is positive. So you have happy eyes. And if it's concave down, you're Mr. Frowny and you're negative. So your eyes are negative because you're down and you're negative. So it's just kind of a way to remember it. If you don't like that, don't worry about it. Okay. The third thing with concavity is there's a thing called the inflection point. So the inflection point is the point where the concavity changes. So it's going to change from concave up or to concave down or vice versa. At an inflection point, the second derivative is equal to 0 or undefined. Again, we mostly will do the equal to 0 case. And the second derivative must change sign. Okay, so it either has to change from positive to negative or from negative to positive. If we have the derivative will change from increasing to decreasing or vice versa at an inflection point. the derivative has a max or a min at an inflection point. Okay, now in this class, we're not going to talk too much about the derivative and concavity. We're going to mostly focus on the original function on the concavity. But these are inflection points. And if these look familiar, inflection points often occur at plateau points. They don't have to be a plateau point, but they could be. And plateau points are usually inflection points. Okay, so let's look at a graph and just identify where our graph is concave up, concave down, and where the points of inflection. So we're going to give them, again, an interval notation. You can also write it in inequality, but we mostly do interval. Okay, so if I look left to right, here my function, I'm looking at how it's curved, up or down. This is definitely curved up. Okay, curved up, and then it's going to change somewhere around 0. So sometimes if we don't have an equation, it's hard to tell exactly where, but this one, it looks like at x equals 0, it changes from curved up to curved down. And then here from 0 on, my function is curved down. So I would say my function is concave up from negative infinity to 0, and it's concave down from 0 to infinity. And then my point of inflection which often we just say PI for point of inflection, would be at 0, 0. So if we talk about in terms of derivatives, we would know that the second derivative of is greater than 0 on negative infinity to 0 because my function is concave up. And the second derivative would be less than 0 on 0 to infinity. And I would know that there's a point of inflection at 0 because my second derivative changed sign. It changed from being greater than 0, so positive, to being less than 0, negative. And then just to summarize the relationship, again, if my function is concave up, the derivative is increasing, okay, because we said that slope is increasing, and the second derivative is greater than 0. Okay, so what that means is it's positive. If it's concave down, I should say is, but concave down, my derivative is decreasing. And my second derivative is less than 0. Okay, or we would say negative. And at an inflection point, the derivative has a max or min. And the second derivative is going to equal 0. And the second derivative must change sign. Okay, it has to change from positive to negative or vice versa, or else it is not a point of inflection. Okay. So this is a summary of the relationship. And again, mostly you need to know is this third column and the first column. We don't talk too much about the first derivative and the second derivative, but we're going to talk a lot about the relationship between f and f double prime.